Hi, my name is Samantha Jensen, and in this video we're going to be solving systems of linear equations by graphing. Before watching this video, be sure to print a copy of the notes so that you can follow along as we go. Also, please feel free to pause or rewind as necessary. Sometimes it's necessary to find the point at which two linear equations intersect. Let's start with a simple example. You want to choose which gym membership is better for you. One gym offers a $15 per month membership fee and charges $2 per visit. Another gym offers a $10 per month membership fee but charges $3 per visit. You want to know when the two memberships cost the same so that you can decide which is the better choice for you. The system you want to solve is y equals 2x plus 15 and y equals 3x plus 10, where x represents the number of visits and y represents the cost per month. There are several ways to solve this system, and we're going to use solve by graphing today. Our objective is to solve a system of linear equations by graphing. Before we do that, let's look at some definitions. A system of linear equations is a set of two or more equations using the same variables. The solution of a system of linear equations is a set of all ordered coordinates that simultaneously make all equations in the system true. The steps we're going to follow are number 1, graph the equations, and number 2, find the intersection point. So let's take a look at our first example. We're going to solve this system by graphing and then check our solution. Now in this initial example, both of our equations are written in slope-intercept form. So in this first equation, we're going to start on the y-axis at 15, and then the slope is 2, which has a rise of 2 and a run of 1. So from our y-intercept, we're going to go up 2 over 1, and I'm going to do several points just to make sure we have a clear line. And then I'm going to use a straight edge to draw my line. My second equation starts at 10 and goes up 3 over 1. So very carefully, plot your points. All right, so our intersection point is going to be this point right here where they intersect, and that's the point 5, 25. That means after 5 visits, both of the prices of the gym membership will be $25. So here's line 1 and here's line 2. So in deciding which membership is better for you, notice that option number 2 is less expensive if you're going to visit for less than 5 times per month. Notice that option number 1 is less expensive for if you're going to do more than 5 visits. So it just depends on how many times per month you plan to join to visit the gym. So it just depends. So option 1 is less expensive for more than 5. And option 2 would be less expensive for less than 5 visits. Now, if we wanted to check our solution, we could plug this ordered pair back into the original equation to make sure that it's true. So if I put 25 in for y and 5 in for x in this first equation, is 25 equal to 2 times 5 plus 15? So is 25 equal to 10 plus 15? Yes. How about the second equation? Is 25 equal to 3 times 5 plus 10? So is 25 equal to 15 plus 10? Yes, it is. So we know we're right. Let's look at another example. Example number 2 is also asking us to solve a system of equations and check our solution. Both of these equations are written in slope-intercept form, so let's graph them. The first equation starts at -1 and goes up 1 over 2. So I'm going to continue that pattern a few points. I can even go down 1 over 2 to the left to continue it that way, and then I'll use my straight edge to draw my line. My second equation starts at 4 and goes down 2 over 1. So I can see right there that it's going to intersect right here on the x-axis at the point 2, 0. So my solution to my system is 2, 0. I can check that solution by substituting the x and the y back into the original equation. So is 0 equal to 1/2 times 2 minus 1? So is 0 equal to 1 minus 1? Yes. Is 0 equal to negative 2 times 2 plus 4? So is 0 equal to negative 4 plus 4? Yes. So we know we're right. Let's look at example 3. Example 3 is not written in slope-intercept form, and I think it'll be best to go ahead and change it so that it is. So I'm going to get y all by itself by adding 4x to the other side. Now I can see that my y-intercept is 3 and my slope is 4. So from 3, I'm going to go up 4 and over 1. 1, 2, 3, 4, and over 1. I can go down 4 and over 1 also. And then draw my line. Now my second equation is not in slope-intercept form. It's more in standard form. So I'm actually going to use the intercept method to graph this one. So when y is 0, x is negative 2. So that tells me there's an x-intercept at negative 2. And when x is 0, y is also negative 2. So there's a point at negative 2 on the y-axis. Connecting those 2 points, I can see that the intersection of those 2 lines is at the point negative 1, negative 1. And you could then check that solution again. Let's just look at the second one. Negative 1 plus negative 1 is negative 2. And if I put negative 1 in here, negative 4 times negative 1 is 4. And 4 plus a negative 1 is 3. In example 4, again we're in standard form. So the x-intercept is 2 and the y-intercept is 2. So I'll plot those 2 points and join them with a line. And the second equation starts at 6 and goes down 1 over 1. Notice in this example, the slope is going to be down 1 over 1 for both lines. So this is a special case where the lines are going to be parallel. And since they're parallel, there is no intersection point, which means that there is no solution to this system. So this is a special case where they're both going down 1 over 1 for their slope, and there is no solution. Okay, so now you've seen a few examples, and now I want you to try. So pause this video and then try examples 5, 6, and 7 on your own, and then watch to make sure that you have them correct. Okay, hopefully you've had a chance to try some of these, so let's take a look at your solution. In example 5, we want to start at 1 and go up 2 over 3. And I'll just do a couple more and maybe go down 2 over 3. So this is the first line. The second line, I'm going to change into slope-intercept form, so that'll be y equals negative 3x plus 12. This one goes off of your graph a little bit. This is 11, and then 12 will be up here. And then since it has a negative 3 slope, that's down 3 and over 1. So I can see that it's going to intersect right there at that point, which is the point 3, 3. And I can check that solution. Is 3 equal to 2/3 times 3 plus 1? Is 2 plus 1 equal to 3? Yes. Is 3 times 3 plus 3 equal to 12? Is 9 plus 3 equal to 12? Yes. Example 6. This one's written in standard form. Let's use the intercepts. So if 2x equals 4, then x would have to be 2, and y is 4, and then connect them. The next one, the x-intercept would be negative 4, and the y-intercept would be at negative 2. So it looks like they are going to intersect. So if I follow this down 4, 1, 2, 3, 4, 1, 2. And if I follow this down 2 and over 4, 1, 2, 3, 4, you can see actually that the lines intersect at this point here. which is the point 4, negative 4. And I can verify that that's correct by substituting those back in. So x is 4 and y is negative 4. So is 2 times 4 plus a negative 4 equal to 4? Is 8 plus negative 4 equal to 4? Yes. How about negative 3 times 4 minus 6 times negative 4? Does that equal 12? So is negative 12 plus 24 equal to 12? Yes. And let's see how you did on example number 7. Example number 7, the x-intercept will be 2 and the y-intercept will be 3. The second equation has an x-intercept of 4 and a y-intercept of 6. So you can see again that this is one of those special cases where the lines are actually going to be parallel. So it goes down 3 over 2, down 3 over 2, down 3 over 2. They have the same slope. So they're parallel, which means they never intersect. So that's no solution. So in conclusion, this method of solving systems of linear equations by graphing is a great place to start because it gives you a visual of what's happening. However, it's not always the most efficient method for solving systems and can be difficult to use, especially if the solution to the system is not an ordered pair of integers. Coming up next, you'll learn how to solve a system of linear inequalities by graphing, and later a few more algebraic methods for solving a system.